Good morning. Today we're going to talk about fractions. This is mostly a review. This is something you've seen in 5th and 6th grade. And we're going to talk about all operations of fractions. What we're focusing on today is, or this year, is fractions with negative numbers or negative fractions and how we can deal with that. Okay? So we're going to go through all the operations, addition and subtraction. Again, I put them together because the same with decimals, they have the same method. And then we're going to talk about multiplication and division, which are only very slightly different. So these two are almost the same, and you'll see the tiny difference that there is in the examples. With multiplication and division, it's actually much simpler. You just multiply the numerator, the first numerator, by the second one, and then multiply the first denominator by the second denominator. So if I have a over b times c over d, my answer is going to be a times c, whatever those numbers are, over b times d. Okay? So keep that in mind. We're just multiplying numerators and denominators. We don't need to find a common factor, a common denominator. We don't need to do LCMs or DCFs or at all. Right? So we do that, and in fact, let me add a third step here, which should be always there in the end, simplify. Once we're done, we simplify. Let me add it here too. Now, with division, it's only slightly different. If I start with keep, change, flip, which I'm sure you've heard before. If I have a over b divided by c over d, it ends up becoming a over b multiplied by d over c. Notice that I flipped this second fraction and I changed the sign, right? And so the result, if we take that one step further, is going to be a times d over b times c. Okay? And the reason we can do that is because division is just multiplication with the reciprocal. Let me quickly show you an example of what I mean. If I have 8 divided by 4, this is equal to 2. It's exactly the same as saying 8 times 1 over 4. Because remember, we said any whole number has a denominator of 1, basically. So if I flip them, if I switch this around, it becomes 1 over 4. And 8 times 1 over 4 equals, if you follow the fraction rules, 8 times 1 is 8, 1 times 4 is 4. So it's 8 over 4. And then, if we simplify, we can divide both of them by 4, because they're both multiples of 4, and we'll get 2 over 1, which is just 2 if you simplify, or if you put it in the simplest form. So division, and make sure you have this in your notes, division, this is very similar to what we said about subtraction. Subtraction, we said, was just addition with negative numbers. And we said didn't really exist, right? The same with division. It doesn't really exist in the sense that you're just really multiplying by the reciprocal. So going back to the rules here, whenever you see division of fractions, you can just flip the fraction and then just multiply. And so you're getting the reciprocal of the second fraction, and you're multiplying. You can actually try this out. So if we want to do another example, here. We can do something like 6 over 10 divided by 2 over 5. This I can just follow the same rules as the multiplication and say 6 divided by 2 over 10 divided by 5, which is fine. 6 divided by 2 is 3. 10 divided by 5 is 2. Now let's compare this to the keep, change, flip rule. So I'm going to keep the 6 over 10, change the sign, and flip the 2 over 5 to make it 5 over 2. Now 6 times 5 is 30. 10 times 2 is 20. If we simplify, we can divide them both by 10. And guess where we end up? We end up with 3 over 2. So we can get the same answer if we do this, but if you get a problem where they're not exactly multiples, if you get something like 7 over 8 divided by 4 over 9, it's very hard to divide 7 by 4. You've got a decimal, and 8 divided by 9, same thing. So it's much easier to follow the rule of the reciprocal and just keep, change, flip, and find your answer. Okay, so let's go back to this. So these are the rules we follow for division and multiplication. And let's do some examples to cement this. So we have 2 over 5 times negative 4 over 3. Again, integer operation rules apply. This 4 is negative. So when we say 2 times, if we multiply the numerator by numerator, 2 times negative 4 over 5 times 3. 2 times negative 4 is, since they have different signs, is negative 8. 5 times 3 is 15. 8 and 15 do not have any common factors, so our final answer is negative 8 over 15. Notice that it doesn't matter where you put the negative sign. If you put it with the 8, if you put it right next to the line, the fraction line, if you put it with the 15, it's all the same. So let's look at this one. This one says negative 3 over 10 times 1 over negative 2 minus 5 over negative 20. This negative sign is exactly the same as this one. It doesn't really matter where the position is. Okay? So in this case, I can do the first step as follows. I can say it's negative 3 times negative 1. I know that the negative sign was by the 2, but I can move it up there. Nothing's going to change. And then in the bottom here, I can say 10 times 2 minus 5 over negative 20. And we'll deal with that in a second. The next step is just simplifying. So negative 3 times negative 1. They're both negative, so the answer is 3. 10 times 2 is 20. And then it says minus, and you have two negative signs here. It's as if you're saying minus 5 over 20. Again, it doesn't matter where you put the negative sign. You can put it in the denominator, the numerator, or right next to the line. It doesn't really matter. As long as it's just one. You're not like adding more. So whenever we see this, we know exactly what to do. This becomes a plus. And we already have common denominators. So our final answer, if we only operate on the numerators, because this is addition, is 8 over 20. Now, in this case, we're not done yet. 8 and 20 are both even. And they're both divisible by 4. So we can divide each of them by 4. And we'll get 2 over 5. 8 divided by 4 is 2. 20 divided by 4 is 5. All right. One last example, and this one has a mixed number. We have negative 3 over 7 divided by negative 3 and 1 over 3. Let me draw this out here. Okay. So when I have a mixed number, 3 and 1 over 3, we already discussed how to turn it into an improper fraction, and let me do that very quickly. Multiply, and then we add. So 3 times 3 is 9, plus 1 is 10, and we keep the denominator the same. So I'm going to rewrite this, negative 3 over 7 divided by 10 over, I'm just going to say negative 3 here, because there's a negative sign here, right? Okay, now what? We keep, change, flip. So keep the 3 over 7, change the sign to multiplication, and flip. So it's negative 3 over 10 instead of 10 over 3. And then now we just have multiplication. So numerator times numerator. Negative 3 times negative 3, they have the same sign, so it's positive 9. 7 times 10 is 70. So we have 9 over 70. 9 and 70 don't have any common factors, so, oops. So this is our final answer. And we're done. All right, if you have any questions, please make sure to email me. If you ever have questions about math-based problems, please take a screenshot of your math space because it's different for each student. So I can't just go in and see what you have. Take a screenshot of it, send it to me in an email, or type it out, and I'll help you through it. Okay? Good luck, and make sure to read the instructions very well. All right? Bye.